Hi, welcome back. In this video, we're going to talk about how to find the greatest common factor of a polynomial. We'll start by reviewing what a greatest common factor is, or GCF, and then we'll talk about how to do this with polynomials, binomials, all kinds of expressions. Before we begin, if you have not subscribed so already, click on the subscribe button so you can see and get access to more videos like this one. Let's begin. So what is GCF? GCF is also known as the greatest common factor. Greatest common factor. So first we want to find the factors of the two numbers we're dealing with. So here on the left we have 12 and 20. We're going to find the factors of 12 and 20 and then find the greatest one that they both have in common. That's why it's called greatest common factor. So for 12, I'll do this in color blue. The factors of 12 can be expressed as 1 times 12. It could be expressed as 3 times 4, 2 times 6. And then for 20, I'll do this in red. We can express 20 as 1 times 20, 2 times 10, 4 times 5, and I'm pretty sure that's it. Just make this one more legible. Now, if we look at all of these numbers, which number do they both have in common? What is the largest number that they both have in common? So they'll both share several numbers in common. I'll do these in, let's do this in black. So notice how they both have a 1. They are both divisible by 2, so they both have a 2. And they're both divisible by 4. Those are all the common factors. Which one of these is their greatest common factor? That's right, the 4. The 4 is divisible into both, and it's also the greatest number. So the GCF of 12 and 20 is 4. Let's find the greatest common factor of 16 and 36. Doing a similar process, we list the factors of 16. That can be expressed as 1 times 16. We can look at it as 2 times 8 or 4 times 4. Similarly, we can make a list of the factors of 36. 1 times itself, so 1 times 36. We can do 2 times 18, 3 times 12, 4 times 9, and 6 times 6. The number that they both share in common, that is the greatest, is going to be, again, 4. I did not plan this on purpose, but they both share 4 as the greatest number that they have in common. So the GCF is also 4. Now, this was a quick review of how to find the greatest common factor, or the number that the greatest number or term that they both share in common. Okay? We're going to follow this up with greatest common factors of polynomials. So let's get actually to this. What does it mean to have the greatest common factor of a polynomial? Well, here we're dealing with multiple terms. We're looking for the greatest quantity or term or variable that both things have in common. What I'm going to first do is looking at the coefficient, looking at the 4 and the 24. What is the greatest common factor of the numbers? Notice how both of them are divisible by 4. They both have a 4 involved. All right, if you want, you can make a list over here on the left. You can say, I'm going to write my factors of 4, the factors of 24. You can say 4 is the same as 1 times 4 or 2 times 2. 24 has more because it's a bigger number, so 1 times 24, 2 times 12, 3 times 8, 4 times 6. Now, out of both of these sides, 4 and 24, the largest number that they both have in common, as I said earlier, I'll circle this in red, is 4. They're both divisible by 4. So when I'm looking at these two, the greatest common factor for now we start with is the number 4. They both have a 4 in common. Now, as I start shifting over to the variables, this one has an x squared and an x. I can also make another column over here on the side, and I can break it into looking at the variables alone. And I can list the factors of both variables. X is just 1 times x, and the other one has x times x. That's what gives us x squared. Notice how they both have an x in common. I'll put that one as well in red. That is the greatest thing that they both share in common. So the factors of the variables are going to be x, and the factors of the numbers, the coefficients, is 4. So the greatest common factor of these two is that they're both divisible by 4, and they both have an x as the greatest term in common. So 4x is the GCF of this expression. Let's try a few more. Here we're dealing with a different variable, but the same idea. What is the greatest term that they both have in common? Technically, this number here in the front is a positive 1 t squared. So 1 and 8, the highest number that they both have in common is a 1. If you want to break it down into the table as I did earlier, 1 and 8. 1 is just 1 times 1, but 8 is 1 times 8, 2 times 4. Notice that the highest number that they share in common is just a 1. So the value that we're dealing with is a 1 that they both share in common. The variable, similarly, they both have a t. This is a t squared, and this one has a t. They both terms share a t. So my common factor here is 1t. If I want to do the columns, I can do that as well if you'd like to organize it. I have a t squared, and I have a t. I'm going to break it down. This is t times t, and this is just t times 1, right? Just t. They both share a t. So I take the greatest common factor of the number, I take the greatest common factor, right? Greatest common factor of the number, greatest common factor of the variable, and 1t is what they both terms have in common. So I'm going to do a series of examples moving forward, and then you feel free, if at any point you feel like you're learning something, click the like button, okay? And stick around to do as many as you feel like you get more comfortable. But I'll be doing a good amount of examples. I'm going to do like 5 more examples that get more complex as we progress. So the last example should be the most complex one. If you're feeling really good after 1 or 2, skip to the end, try the last one out, and see if you're good. So I want to factor out the GCF, and I want to rewrite this expression so that it has the same value, but now with GCF being one of those factors. Okay, so I'm going to list the things that all 3 have in common. Okay, so with the numbers, notice how they all have a number. What is the greatest common factor of all of them? Or what number can I divide into every single one of these terms that is the highest? 1 goes into all of the numbers. 2 does not. 2 goes in here, but not into 9 and 27. 3 goes into 6. 3 goes into 9, and 3 also goes into 27. 6 goes into here, but not into here or here. So I'm looking at the highest number, and the highest number will be 3. Okay? Eventually, we won't have to make a table, but I'm going to start with the table for now. I have 6, I have 9, and I have 27. So 1 times 6, 2 times 3. 9 is 1 times 9, and 3 times 3. And 27 is 1 times 27. I have 3 times 9, and those are my only options. Notice how out of all of these 3 columns, what is it that they all have in common? The greatest number that they all have in common is that 3. 3 is the highest number that all of the terms have in common. So 3 is the GCF of the numbers. Let's look at the variables. Here for the variables, this one has an x, This has an x, but this does not. So in the variable situation, they're not all going to have an x. So I cannot find a factor where I can pull an x out of all of them. So I do not make a table over here because they would all need to have the same variable to pull one out. So 3 is the GCF, and this is what I do. I'm going to write this as 3 times something is going to bring me back to where I started. So I'm going to factor out a 3 from every situation. I'm going to divide this by 3. If I divide 6 by 3, I'm going to get 2 x squared. If I divide the second term by 3, I get 3x. It's positive 3x. And if I divide the last term, positive 27, by 3, I get positive 9. I write my GCF on the outside, and then on the inside, I write what's left over. Now, if I go backwards and I do distributive property here, notice how, if I distribute, 3 times 2x squared is 6x squared. 3 times positive 3x is positive 9x. And 3 times 9 is positive 27. So these two expressions are identical. One of them is written in this format with 3 terms, and here, this one is written in terms of its factors. I was able to factor out a 3 from all of the terms, and now I can express this as these are the two factors, 3 and 2x squared plus 3x plus 9. So I factored out a 3, and the rest of the polynomial, is what was not factored from it. So this is what I'm looking for. I'm looking for a way to express the exact same statement as the original statement by first pulling out a GCF. And when you factor out a GCF from the polynomial, you're left with a much simpler polynomial in the inside. This is what we're looking for. Factor the GCF and what's left over. So let's give this a try. I have 3 terms. Let's look at the values, the numbers. What do all 3 numbers have in common? What's the greatest thing that they are all divisible by? And yes, they all are divisible by 5. This can be divided by 5, this can be divided by 5, and that can be divided by 5. If you want, make a list over here of all the factors of the numbers, and you're going to see that 5 is the highest factor that they all share in common. So the GCF is 5. What about variables? Do they all have the same variable in common? This has an x, but this one does not have an x. So I cannot factor an x out of all 3 terms, just the number. So once I have the GCF, I'm going to multiply it by something. And all I'm really doing is I'm going to divide each term by 5. If I divide this by 5, if I pull out of 5, I'm left with x cubed. If I divide this by 5, positive 30x squared, if I divide it by 5, I'm left with 6. Positive 6x squared. And if I divide the last term, negative 15 by 5, I get negative 3. And those are my factors. I factored out the 5, and I have 5 times this polynomial. Again, if you want to check your work, you can multiply, you can distribute, and if you distribute, you should get back to the original statement. These two statements are identical. They're just written where one of them has the GCF factored out of the equation. Let's try this one out. Let's look at the numbers first. What is a number that can be factored out of all of them? Notice how they're all divisible by 2. 2 goes in here, 2 goes in here, and 2 goes in here. Can 6 go into all of them? Well, 6 can go into itself, 6 can go into 12, but 6 does not fit into 2. So my GCF here is 2. That's the number that they all can fit in. So 2 is my GCF. What about variables? This one has an A. Sorry. So this term has an A, this has an A, but this one does not have an A. All of them have to have a common value. This one has a B, this one has a B, but the first term does not have a B. So I cannot factor out a variable, just the number. And this is where we go with the parentheses. So 2 times what will give me back to my original statement, right? If I divide the first part by 2, if I take out a 2, I'm left with just a squared. If I look at the second statement, divide this whole thing by 2. 12 divided by 2 is 6. It's a positive 6, and then the variables are just attached. That's supposed to say positive 6ab. That looked a little weird. And then lastly, if I look at the last term, I'm just going to make some space here. If I look at the last term, (6b squared). If I divide the last term by 2, 6 divided by positive 2 is 3. And that leaves me with a positive 3b squared. And those are my factors. 2 and a squared plus 6ab plus 3b squared. Again, if you want to do FOIL method or distributive property here, sorry, not FOIL. If we distribute, we can do 2 times a, we get 2a squared. 2 times 6, we get 12ab. And 2 times 3, we get 6b squared. Let's do 2 more. Okay, so here I want to find the GCF and rewrite it as an equivalent expression. The numbers, they're both divisible by 6, so I'm going to factor out a 6. Do they both have a variable in common? They do. They both have some sort of a. Now, what is the largest a value that I can take? A is the largest value. If I had a square, I can pull out a square from both of them. I'm looking for the greatest value I can factor out, and they both have an a. They don't have a b, but they both have an a. So I'm going to factor out a 6a. So I take the first term, divide that by 6. If I pull out a 6 and an a, I'm left with a squared. If I factor out the next term, if I divide negative 18 by 6, I get a negative 3. And if I factor out an a from this term right here, if the a comes out, I'm just left with the b value. Because the a came out. Again, we can always distribute and see if our answer matches our previous statement. Right? 6a times a squared is 6a cubed, and 6 times 3 is negative 18. A times b is ab. These are my factors, where 6a is my GCF. Let's try one last one. Okay, again, we start with the coefficients. Let's start with the numbers. Are they both divisible by 7? Yes, 7 fits into both. So 7 will be one of my factors. What about the variables? Do they both have an a? Yeah. What is the highest exponent that they both have in common? This one has an a squared, and this one has an a cubed. So the highest a that I can pull from both is going to be an a squared. What about for b's? This one has a b cubed, and this one has a b to the 5th. What is the highest b value that they both have in common? They both will have b to the 3rd power in here. They both fit in there. So the highest value that I can pull out is a b cubed. Okay? If you wanted, you can make a table with the variables, and you can see how many a's and how many b's can I pull out, right? And we can walk you through that here in a little bit. So if this is my GCF of both terms, now I have to factor it out from the original expression. So, in the very beginning, 7 divided by 7 is just 1. A squared divided by a squared is also 1. And b cubed divided by b cubed is also 1. So I took out the entire thing out, leaving me with just 1 in there. Basically, this divided by itself is 1. What about the 56? Negative 56 divided by 7 is going to be negative 8. That takes care of that part. If we look at the a cubed, we pull out an a squared. How many a's are we left over? If we have 3 total and we pulled out 2, we're left with just 1 a left over. And same thing with the b's. I have b to the 5th power and I have b to the 3rd. If I pull 3 of them out, I have 2 b's left over, so I left with b squared. And these are your two factors. 7a squared b cubed times 1 minus 8ab squared. The 1 here is extremely important because if you distribute this times 1, we go back to the statement. And then this times the 8 is 56. A squared times 8 is a cubed, and b cubed times b squared is b to the 5th. Here are my two factors. If you struggle with the variables and you're like, how do I know how to move the variables and how do I know where things go, right? We can talk about that here in a second. You can always make factoring variables a table on the side. So I have a squared b cubed for the first term, right? And the second term I have a cubed b5. So a squared is just a times a, and b cubed is b times b times b. On the other side I have a cubed, which is a times a times a. Sorry about that. And then b to the 5th means we have b times b times b 5 times. So when I'm looking at the greatest common factor, I first start with the variable, right? The letter a. They both have 2 a's in common. That's why I factored out an a squared. And then when I was looking at the b's, they both have 3 b's in common. So I was able to pull out a b cubed. With the numbers, I can make a table on the left as well. That's how we started this process. 7 and 56. This is just 1 times 7. This one is 1 times 56. We have also 2 times 28. And we have, let's see, 7 times 8. Notice how they both, the greatest value that they both have is a 7. That's how I chose this 7 to come out. So I factored out a 7, I factored out the a squared, and I factored out the b cubed. Right? I'm looking for the greatest common factor in numbers and in variables. And then in the end, ideally, we just deal with this blue part. I'm able to factor out a number, they both have an a squared, and they both have a b cubed. This black part that I just wrote is just more explained and more simplified in case you needed another explanation. Please let me know if you have any questions below. If this helped you, click the like button. If you haven't subscribed, go ahead and do so already. And as always, we'll calculate later.